Have you ever wondered what keeps your feet on the ground, or what holds the moon in a graceful, endless dance around the Earth? For a long time, we thought of gravity as an invisible rope, a mysterious force pulling things together, but the truth is far more strange and wonderful. The universe isn't just an empty stage where things happen. Space itself is a real physical thing. It can be stretched, it can be warped, it can be curved, and it is the most massive objects that bend the fabric of reality. Stars, planets. The effects of gravity are not a pull, they are a push from space itself. Imagine a huge, flat, stretchy rubber sheet. This sheet represents space, space-time. Place a small, light marble on the sheet. It just sits there. The sheet remains almost perfectly flat. This is like a small asteroid in deep space following a straight line through flat space-time. Now try something different. So, we have our bowling ball sitting in the middle of the rubber sheet, creating a deep well. Now, let's roll that small marble from before. Instead of rolling in a straight line across the sheet as it did when it was flat, the marble's path is now different. As it gets near the bowling ball, it gets caught in the curve. It begins to circle the heavy ball, rolling around and around the dip. It is now in orbit. This is exactly what the Earth is doing as it travels around the Sun. It is simply following a straight line through curved space-time. The Earth is constantly trying to move forward in a straight line, but the Sun has curved space-time so deeply that the Earth's straight-line path becomes a closed loop. We call that loop an orbit. The Earth isn't being pulled by an invisible tether. It is simply moving along the curve in space-time created by the Sun's mass. The Moon orbits the Earth for the same reason. The Earth, though much smaller than the Sun, creates its own dip, and the Moon is caught in that local curve. This beautiful and elegant idea was given to us by Albert Einstein. His theory of general relativity, matter, tells space-time how to curve, and curved space-time tells matter how to move. This continuous feedback loop is the engine of the cosmos. Now, what about something that has no mass, like light? Does it also get affected by gravity? The answer is yes, one of the most spectacular predictions of Einstein. Light always travels in a straight line. It takes the shortest possible path between 2 points. But what is a straight line in a universe that is curved? If space-time is bent, then the path that light follows through it will also be bent. It's still the most direct route, though it appears curved to us. Imagine an ant walking across our curved rubber sheet. The ant thinks it is walking in a perfectly straight line, but from above, we see its path is bent by the depression. So too with light from a distant star passing near the Sun. The ray follows the curve and appears shifted when it reaches us. This effect is called gravitational lensing. It was first observed in 1919, just as Einstein predicted. Today, we use it as a powerful tool to see farther into the universe. Massive clusters bend and magnify light from even more distant objects. The most extreme case is a black hole, so dense it makes an impossibly steep curve that even light cannot escape. So, the next time you look up at the night sky, think about what you are really seeing. You are not just looking at a collection of bright dots hanging in a void, you are looking at a dynamic, interconnected system governed by a simple and profound principle. Every star, every planet, every galaxy is actively shaping the universe around it. They are participants in a grand cosmic dance, and the dance floor, space-time, is being warped and reshaped. This constant interplay is what we call gravity. Get a bed sheet. Friends, hold it taut. Place a heavy melon in the center. Now roll a few marbles across the sheet. They curve around the melon, some settle into orbits, others are flung in new directions. Add a smaller weight, an apple, and try to orbit it with a tiny bead. You've created a miniature solar system. This thinking lets us predict orbits, send spacecraft, and model stars, galaxies, even the expanding universe. It led to the discovery of gravitational waves, ripples in space-time.